We are in AP Calculus. Arrow is having a bad hair day today. Today's date is Thursday, November 14th. It was the event. It's not like bad hair. 2019, we're talking about general n power antiderivatives. So we need to find the harder ones. So I need to find, oh yeah, objective. Geo laptop shut. Objective, someone.
Complex general and
Complex powerhouse functions of both of those.
It's kind of disrespectful.
It's fine.
You got it last time. You were supposed to give it to her, and then you interrupted her.
I'm sorry. Let me do a
apology.
Well, I need a
So-
1,000-word apology letter, please.
Okay,
That's
no.
by the end of it.
Paying the taxman. That's what we're learning today. And it's a method to help you take the antiderivative whenever, and when do you use this? When do you use the paying the taxman method? The answer is whenever your dinner is not 1. So if your dinner is 2, a half, 5, negative 1,298.37, those are all not 1. Those are all of the things that you're going to use taxmen on. In general, I think that this was probably, if I had to name the biggest mistakes for the entire, all of AP Calculus last year, it was people forgetting that you needed to do taxman. Once you knew you needed to do taxman, then like doing taxman was pretty easy. But knowing that you needed to do taxman, you always have to check your dinner. If your dinner is 1, you're good. You don't need to worry about it. And it's kind of weird to think about dinner if you're going backwards, right? Because dinner is going forwards. So you have to check dinner and then go backwards if, well, you're always going to go backwards, but then you'll use taxman to go backwards. So here we go. 3 easy steps. First, you need to find u. Should I make the obvious joke?
You're right there.
Haha, there it is. Error remembers. You need to find not only u, but taxman. U taxman, and I'll call it u prime. If you find those 3 things, it sets you up for success.
So, U is inner, taxman is whatever taxman is, U prime is inner.
Precisely, yeah. So let me talk about it over here. Here is a function. Do I need to use taxman on it, first of all?
Yes.
Why?
Because there's dinner.
What is inner? Before I take the...
X plus 1.
Yeah, so this is the inner. Take the derivative of that stego. 4. Is 4 1? Therefore, I need to use taxman. This is the same thing. You need to really get in the habit of just always asking yourself the question. What's dinner? Oh, it's not 1. Okay, taxman. So I need to use taxman. So I'm going to write out these 3 things. U. What is our u? We already listed it. 4x plus 1. Next, we're going to write out taxman. I'm just going to write tax. Well, you can write taxman if you want. You can just write tax to abbreviate. Taxman. So when the taxman comes, he usually knocks on the front door. Sometimes he knocks on the back door, but it's whatever is outside of your house. He's knocking on the house. The house that we're in is Powerhouse. You guys see Powerhouse? There's Powerhouse. Oh, who's knocking on the front door?
8.
8. 8 is your taxman. I mean, if I was being formal, I'd be like, it's the coefficient. But yeah, there it is. Taxman is 8. And then what is u prime? U prime is equal to 4. Notice the spacing here. I wrote 4 directly beneath 8 because what I'm going to do is I'm going to do step number 2, which is,
I have to erase it and rewrite it.
Yeah, I have a pen.
it doesn't matter that much.
You just weaved it in.
Yeah, Geo, you need to be nicer. Step number 2 is to pay the taxman.
Where's the wig? Can I change who wears the wig?
No.
Just know this for next time whenever you're allowed to deal out damage.
I know.
You need to pay the taxman. That taxman won't go away, and sometimes he'll never go away, until you pay him. So what do you pay the taxman with? You pay the taxman with this nice little fraction here. I'm going to turn this into the fraction 8 divided by 4, which is equal to 2. That taxman has been paid. I'm changing the taxman from an 8 to a 2. I've paid the taxman. So this is now, I haven't taken the integral yet. The integral is still there, and I have, now it's instead of 8, it's 2, and I leave the house. The house, obviously, I can't move an entire house, so 4x plus 1, power of 3 dx. I have now paid the taxman. And then step number 3 is actually to take the antiderivative, which is what most people do without doing steps 1 and 2. They forget, oh shoot, I was supposed to use taxman. Then you actually antidifferentiate, or you find the antiderivative. Antiderivative. All right, so here we go. Take the antiderivative. The 3 is going to go to what power? Okay, so I'm going to write out 2 times 4x plus 1 to the power of 4. And then do what with 4? Divide down. So I can just leave that out front. That's fine. And your third step that most people always forget. Nope.
Add C.
Add C.
Oh, yeah.
So then it's
So your final answer, Claire, is?
x plus 1 to the 4th over 2.
Yeah, you can write it that way too. And it seems like, oh, that was actually really easy. And that's the whole point of Taxman, is it simplifies the process.
That's it.
That's it. And I'm glad you're saying it. It's like, really? That seemed easy, right?
Yeah.
Taxman is easy. The hardest part about Taxman is knowing that you need to do it. You always have to check this dinner. Can we like circle or write a star or something? This dinner not equal to 1? That is the hardest part of Taxman, knowing that you need to use it. Always be checking. Whenever you're going backwards, check your dinner. Is it 1? If it's not, you need to use Taxman.
Wait, so from now the point on, we always have to use taxman to everything.
Well, for example, if I take the integral of 3x squared, do I need to use Taxman?
No,
Why?
because they don't have an inner.
Well, the inner is x,
My inner is 1. Wait.
and dinner is 1. Yeah. The inner here is x. Therefore, my dinner
It's 3.
is 3, not 3. My dinner is 1, because the inner is just x. Take the derivative of the inner. Derivative of x is 1.
Oh, okay. Gotcha.
So essentially,
Basically,
use Taxman whenever you have some inner that's not x.
Basically, when
When
you
you
have
have
Yeah, that's another good way to think about it. But again, that is the hardest part about Taxman, knowing to check for your dinner. Okay, that is super, super informal. And if there are other people that are watching this YouTube video that are like proper mathematicians or went to a real, I was about to say real high school, that went to a high school that doesn't teach Taxman. Because I don't know, I always feel guilty teaching this type of curriculum because like it's not proper, but it makes you get the high score on the AP test. This will give you the antiderivative correctly every single time. However, there's the formal way of showing it, which is how you are going to answer a few multiple choice questions. Some multiple choice questions will ask you, oh, what was your U when you used your U substitution? You'll be like, I used Taxman. I don't have any U. I have to teach you the proper way. If you talk about U substitution to people in China, India, people that don't even speak English, if you say U substitution or you show them U substitution, they will know what you're doing because this is very formal now. So again, when do we use this? It's the same thing when we use Taxman. It's when dinner is not equal to 1. Essentially when I have an inner that's not x, like x plus 1. Say again?
Sometimes when you can't use Taxman, only use substitution.
There are a few cases where U substitution is easier than Taxman, yeah. That generally almost never happens. But let's try it. So for this one, you'll have to find 2 fewer things. Instead of finding U, Taxman, and U prime, you just have to find U. And I'm not going to write it U prime. I'm going to write it du dx, which is U prime, but again, I'm being formal now. And trust me, by writing it more formally, it is easier.
Hi, Arrow.
All right, Arrow, you can finish watching the video at home. All right, hi, Arrow. You are now watching me in the future, and this is how you do this. We're going to find U. Everyone, U is what?
It is 4x plus 1.
4x plus 1. Therefore, du dx is what?
4, right?
It is indeed 4. All right. We have a lot of steps to go. Like, notice the difference between Taxman and U substitution. Taxman was 3 steps. This is 5 steps. And these 5 steps are tricky. So, next step. Guys, we are teaching a lesson. This is why we lock our doors. I just needed to do that. It felt good. Karmic.
That's what they
in the spot.
Next, we need to get d of x isolated. So just get your d of x. So notice here I have a fraction, du dx. How do I just get d of x? Well, first I need you can either cross multiply, you can take the reciprocal of both sides. I don't know what's easiest for you guys. Maybe taking cross multiplying is a little bit more familiar to us. So let's cross multiply, yeah? Cross multiply, I get, I'll go yellow that direction, green this direction. So if I do that, I get 4 dx is equal to how many du's? Just 1 du, right? Or just du?
So then dx is equal to du divided by 4.
Indeed, yeah. So we have, ooh, what happened there? Dx is 1/4 of du, which is kind of cool to think about. We haven't really played with dx's and du or like anything yet. Eventually that formal definition of dx is going to come. I don't know when it is. Sometime. We've got dx by itself, step number 3. Step number 3 is to substitute. I know. Is to substitute u and dx. So check out what we got. We got a u up here. Everyone see the u?
Yes.
We got a dx down here. Everyone see the dx?
Yes.
All right, here we go. This 4x plus 1, this 4x plus 1 is now a u. All right, so write it out. This is now the integral of 8 times u to the power of 3. What is this dx? That dx turns into a 1/4 du. Again, you're starting with the original problem. What can you substitute out? Well, I know I can substitute out the 4x plus 1. I can substitute out the dx. All right, and I'm going to simplify this off here to the right-hand side. 8 and 1/4 simplifies to what? 2. Yeah, so let's rewrite this as, this is the antiderivative of 2u to the power of 3 du. Step number 4 is to antidifferentiate. So antiderivative. Antiderivative. So look at our yellow equation over here. 2u to the power of 3. Take the antiderivative. Go.
6u.
No. You're taking the derivative. Oh man, you're close.
Plus 8.
No, you said 2/3. It's 2/4.
Oh, right.
So first, rewrite it out. 2u to the power of. It's not 3 anymore. It's
4.
4, and then divide down. And then don't forget your.
C.
Yeah, you guys were about to say your
Seven.
dinner, but that's
Seven.
good. Yeah, your cake. And again, that simplifies to 1/2 u plus c. And then finally, can you guys guess what we're going to do with that u?
We're going to substitute it.
Yeah, plug u back in, or sub u back in.
Wait, does the power of 4 still go on?
Yes. Sorry. Log it.
Ooh.
Yeah, keep me on point. Thank you, Stego.
So now we what?
Now we sub u back in. So this u right here, guess what that u is?
4x plus 1.
Oh, yes, it is indeed 4x plus 1. So we have 1/2 4x plus 1 plus c. And yeah, check that out. It should be the same answer as we had. Oh my God, Geo, thank you.
Log it.
Keeping me on task. Log it. Yeah, it's the same answer that we got up here. We should be boxing these, by the way. It's the same answer, a different method. This is the more formal method. And some AP multiple choice questions will ask you, what should your u be? And sometimes it's a hard question because it'll have like a bunch of trig functions. You're like, it could be that one or that one. The only way to determine which u you should actually use is by practicing. Like, I'm going to try it this way. And you'll realize, it didn't work. So do I have this in my notes? No, but I remember this from last year. You can never pay taxman with a variable rate. Can we please all write that down? Never, ever, ever, maybe in all caps if you're that type of person, never pay taxman. Taxman is all one word. Taxman, a variable rate. I.e. 2x. 2x is a variable rate because it has a variable in it. You can't say, hey, taxman, I'm not going to pay you my taxes of $1,000. I'll pay you 2x dollars. Like, no, I don't do algebra here. I need taxes. I need a number. I need some quantity of money. Never, ever pay taxman a variable rate. If you do, it will break. It will also break u substitution as well. It will.
How does it break?
I think we see an example in our homework. Let's pull that up. I'll help you on the first few problems on the homework. Worksheet 5-2. So let's see something that breaks it. Number 8. Number 8 will break taxman. Because paying the taxman will not work because you're paying him a variable rate. So let's go through it, right? Taxman. First step is to find U, find taxman, find U prime. Good. What is U? X squared plus 1. What is taxman? Yep, there's no guy out front. So, and what is U prime? 2x. We're breaking Mr. Sindell's rule. We're going to have to pay taxman with a variable rate. Let's try it.
Question.
Yeah.
Oh, because this is okay. Let's think of it.
If I go ahead and try taxman now, this is what should happen. I'm now going to have a 1 over 2x integral of, or sorry, the integral should be out here. The integral of 1 over 2x is now our paid taxman, our x squared plus 1 quantity squared dx. That seems like it should work, right?
Yeah.
You just take the antiderivative. Well, as long as you give yourself room, because you need to find another method. Maybe you can say this right-hand side over here is for doing it the right way. Because eventually you do need to find a method that does work. And I'll give you a hint at the end. Or maybe you already know it. But if I go ahead and take the antiderivative, that 1 over 2x, how do I antidifferentiate 1 over 2x?
You multiply by 2 or divide by, I don't know. Oh, wait. 1. Yeah.
So it's
No, wait, it's x.
1/2 is another name for 1/2 times 1 over x. And 1 over x, I haven't taught you this yet, but you can probably go backwards.
Is it log house?
Say it again?
Log house?
Log house, yeah. Log house. So this is really 1/2 log of x. Log of x. But that's being multiplied by a second function. Whenever you're multiplying, you have to go backwards product rule, right? And I haven't taught you how to do backwards product rule, so that's why you get stuck.
Okay.
You could try saying, oh yeah, just bring the, like you could make this, I don't know, x squared plus 1 to the power of 3 divided by 3. Oh, and then I have to multiply those together. The thing is, when you multiply these together and take the derivative to check your work, the derivative does not go back to this thing. So, how are we going to do it?
no, does not exist.
I'll give you guys a hint here. Here's my hint, and I'll have you guys figure it out from here on out. There's your hint.
So you have to do.
X squared plus 1 in the top and then the side too.
Yeah, you guys figured it out. X squared plus 1, x squared plus 1. Actually, take the square first, so you get x to the power 4, x squared, 1, x to the power 4 plus 2x squared plus 1. Oh, if I antidifferentiate that, that's what we learned yesterday. Yesterday we said, oh, if I have the antiderivative of basic functions, it's the distributive property. Take the antiderivative of this, then antiderivative of this, then antiderivative of this, add them all together, add your c, you're done. It's actually pretty easy. X to the power 4 turns to x to the power 5, divided by 5, 2x to the power of 3, divided by 3, this can turn into x.
Do you still need dx?
Dx?
Oh, for the
Wait,
with the big less.
I do, yeah, log it. So this should now be all of that
Yeah, a lot of mistakes
d of x. Yeah, it's lovely. All the extra credit, right?
Yeah. Doing it on purpose.
Let's go with that. Yeah, so number 9 is going to kind of be the same way. Just go ahead and really quickly show that you're going to get a variable rate. Once you hit a variable rate, at least with number 9, you can stop because you showed it for number 8. Definitely learn how to do number 9 the correct way. I'm going to put at least one of those in the test. Or I'm going to give you something where taxman breaks unless you do some multiplication or some trick. There's always a trick. If I gave it to you, there should be a way to do it. That, I think, is good for the lesson. Yeah, good luck, guys.